So if we're doing number 1, what's something easy? Easy to fill in. Oh, okay, domain. I started hearing all real numbers. Why are you saying it's all real numbers? Yes, it has arrows. All real numbers, negative infinity, less than x, less than infinity. Okay, what's something else easy to fill in? The what? Okay, x and y intercepts. What's the x-intercept? -2, 0, and 6, 0. Y-intercept's also not that bad. What's the y-intercept? 0, -3. What else is easy to fill in? Vertex. Vertex is an important point. What's the vertex? 2, -4. Okay, minimum value. What would the minimum value of that graph be? So does that have a low point or a high point? A low point. What's the lowest y value on that graph? Y value. -4. Good. Did anyone notice this? They match. 100% of the time, they match. The y value from your vertex, and then the minimum value or maximum value, depending on which way your graph goes, will always match. Okay? What's something else you can figure out? Up or down? That should be easy. Is it opening up or down? Up. Which means you have a positive graph. What's something else we can figure out? Axis of symmetry. It is always a vertical line going through the vertex. It always starts with x equals 2. Look here. That's there. Okay. What about the range? That's our last part. Y is greater than or equal to -4. So that vertex helps fill in 3 additional blanks, not just the vertex blank. I told you all yesterday, vertex are a big deal. They're a big deal. Okay. So I want you to do number 2. I'll see number 2. Comments? Questions? Concerns? Okay. So go ahead and get the other paper. The one that I dropped in. Before we start going through it, we're going to talk about okay. These two, here. That has been every single form we have looked at for our parabolas. That's also a similar form that we have done with factoring, right? They were all in that form before you factored. They were all in this form. That's called standard form for quadratics. We just finished talking about it. If it is in this form, so the problems y'all did yesterday, you can see the y-intercept when it is this form. What's the y-intercept? 3. What's the y-intercept for the second one? So that C value, the part at the end, your constant, that's your y-intercept. There's also something else you can see from here. You can tell if it's going to open up or open down from this standard form.
Negative x squared.
This one is going to open up, and this one's opening down. So Kate, want to say that again?
The x squared.
It's the x squared part. So that A value, is it positive or is it negative? Positive opens up, negative opens down. Up, down. Okay. Knowing that, we're going to now start going to that other paper, which is here. I want you to grab that. Is there something you can already tell from that form? You already know the y-intercept. What is it? How are we going to get the other points? How are we going to fill in the rest of that table? Yeah, use your calculator. Put it in the, get your calculator out, go to the graph section, plug in that equation, pull up your table with Control T. Okay, so if that's a graph, what's the vertex? 2, -1. What is the x-intercept, or sorry, the y-intercept? 0, 3. And how many x-intercepts are there? 2, and they are 1, 0, and 3, 0. Okay. So this is our standard form. Well, whether or not you knew it, we were having things in standard form and we were factoring them. So let's do that. Let's factor this. Take a stroll down memory lane of last week. If I want us to factor that. First term in the first box, last term in the last box. Numbers that multiply to give you 3, but what else do they need to do? Add up to -4. So what are those going to be?
-3.
-3 and -1. So -x and -3x. So at the top, x -1, x -3. Remember factoring? Okay. So that means this is really this. Yes? Okay. So then I'm going to turn this back to, it had a y equals in front of it. So let's put the y equals back with it. So x -1 and x -3. Now get your calculator back out. Do not delete the parabola you currently have on there. Press tab. Press the tab button. So that means you have a new blank bar at the top. Type this one in now. X -1 and x -3. Make sure you put in those parentheses. Okay, get it out the table first. So some of y'all just, I heard it turned purple. Why? They're the exact same thing. They are matching perfectly. So those of y'all that are still struggling with factoring, helpful hint, how you can check your answer. Put this in your calculator, then put that in the calculator in the graph section. They should be purple because that means you get it right. They are the exact same thing. So this here is standard form. That is a form that we write our quadratics in. This is also a form. That is called factored form or intercept form. We're going to talk about that part, but that is another form. Same thing, it's just written a different way. Let's go back to this part where we factored. What if I wanted to solve for x on it? Like, how do I go a step further? After factoring something, how do I solve something now?
-1
Equals 0. Set them both equal to 0. So what would this x value be? Okay. So x equals 3. How come the numbers 1 and 3 are familiar to us? Where did we see them earlier? When we solve quadratics, they are the x-intercepts of that parabola. When we solve quadratics, those are the x-intercepts of a parabola, right here. Okay. What about the x-intercepts and the vertex? We talked about it already. What's the relationship between these x-intercepts and the vertex? The vertex, the x value is halfway in between the two x-intercepts. Keep that in mind. We're going to talk about that again, so don't forget. Let's go to the next page. So this is another quadratic. But that is now in our factored form. Factored form, or called intercept form. Why do you think it's called intercept form? Yeah, if we solve it, those are the x-intercepts. That's why it's called intercept form. This is the general one for it. A would be like your GCF. Did you have to factor out a number first? Like, did you have to divide everything by 4 first? That's what that A is talking about. And then these are coming in for your x-intercepts. So that's what this factored form, this intercept form is representing. We're going to break our two factors apart. We're going to graph those two. We are going to graph this one here. And we are going to graph this one here. Before we graph it, do this part. From our factored form, what's our intercepts? What are the two intercepts from that parabola? Right here. 2 and -4. Right? We know that it's going to be 2 and -4. When we have the parabola version, because we'll get to that in a minute. Let's do just the factored version. If I graph this thing box in pink, am I going to graph a parabola? No. What are you graphing? What would this give me a graph of? A line. Right? That's slope-intercept form. Our y-intercept's -2. What's the slope? 1, so up 1, over 1. What if I graph the green one? Where do I start? Y-intercept at 4. What's the slope to that one? 1. Anyone notice anything? They're parallel lines. Oh my gosh, what else do they do? They're not touching? Okay. Let's now go into this part. What I want you doing. Clear your calculator. And now type this in your graph. What kind of graph is this going to turn into? What type? Parabola. Yes, that is a quadratic. That's our factored form. Type that into your calculator. I want you to graph it. We talked about qualities of a vertex. Do we know the x-intercepts of this parabola? Yes. What are they? 2 and -4. We know these are going to be the two x-intercepts. We talked about it earlier. If we know the x-intercepts, we can figure out the x value of the vertex. If the intercepts are at 2 and -4, what number is in between 2 and -4? Add them together. divide by 2. We know the x value of the vertex is going to be -1. So that's going to give you now at least a direction to look in your table for the vertex. What's the y value corresponding with that? It should be in your table already. You shouldn't have to do work for it. -9. So there's our vertex. And then we want to copy this graph. As you are graphing parabolas, it is not going to be okay if you just graph the vertex and then draw something that looks like you and kind of matches. You need to physically show those points. Here's our next set. Remember, you just have to get one side, and then you can get the other side matching up. Okay, so now what do we notice about those lines and the parabola? Their x-intercepts match up. The lines and the parabola intersect at those x-intercepts. That means those lines, when they are parallel and intersecting with that parabola at the x-intercepts, those lines are called our linear factors, because they are the lines that intersect with that parabola. They were the factors of that parabola. They intersect at the x-axis. Or the x-intercepts. Okay. I've asked y'all this question for part E at least 3 times today. Now let's write it down. How is the x-coordinate of the vertex related to the x-intercepts? How are the x-intercepts related to the x-coordinate of the vertex? It's in the middle. It's right in between. Which means if I ever give you x-intercepts, you can tell me the x value of the vertex no matter what. If I give you the equation, you can also get the y value, but we'll get to that. Turn to the next page. We're actually going to do number 2 before we do number 1. Looking at number 2, I want to figure out the x-intercepts. This is in factored form. This is intercept form. That means I can get the x-intercepts right now. What would the x-intercepts be? 1 and 9. What would the next one be? And what about the last one? -7 and -1. Now we're going to go up to A. These are the solutions. What's solution mean? The x-intercepts. So if I give you the x-intercepts, how could you go backwards and write the 2 factors? What would it be for A? X minus 2 and x minus 5. What about for B? X plus 2, x plus 5, and what about C? Okay. Now let's go down to the next part. Notice this A and this A are matching. So it's the same thing. But now the directions are, I want to find the x value of the vertex. How can I find the x value of the vertex? What did we just talk about last time? There we go. If we know the x-intercepts, which the x-intercepts are 1 and 9, add them together, divide by 2, that's the x value of your vertex. sits in between them. So 5. This one matches up here, so the X-intercepts are 6 and -2, which means, what's the X value of that vertex? 2. And then if our X values are -7 and -1, what's the X value of the vertex? -4. Okay. Now we're going to do same equations. So we're going to still use y equals x minus 1 and x minus 9. On the next one, we're still going to use y equals x minus 6 and x plus 2. And then we're still going to use y equals x plus 7 and x plus 1. But now our goal is find the vertex. So we already know part of the vertex. What do we already know for the vertex? All the x values. We know that this one is 5, this one is 2, this one is -4. What do I do for the y value?
Plug it in.
Plug it in. If we're given a number for x, plug that number in to get your y. 5 minus 1, and then 5 minus 9. So this is really saying 4 times -4. So what's the y value of my vertex? -16. Good. Same thing for the next. If you're given the x value of anything and we need the y value, plug that x value into the equation. Then solve for y. So that means it's going to be 2 minus 6 times 2 plus 2. 2 minus 6 is -4. So -4 times 2 plus 2, which is 4. So what's that y value? -16. Same thing for the last one. -4 plus 7, -4 plus 1. It's -4 plus 7. 3. What's -4 plus 1? So what's the y value of that vertex? -9 for the y value. Okay. Let's just talk about the last part. Let's do one of them. That way we have an idea of what's going on in this world. I am now still given factor form, but I want to find the y-intercept. We know the x-intercept, we know the vertex, we know lots of stuff about it, but I now want to find the y-intercept. How do you find the y-intercept of anything? Plug in 0 for, okay. That means it's going to be 0 minus 1 times 0 minus 9. What's 0 minus 1? -1. So this is really saying -1 times -9. So what's the y-intercept? 4 as an ordered pair. 0, 9. Getting a y-intercept is still the same as before. Plug in 0 for x, that's how you get a y. Okay. So